weird for you to see because I have a widescreen monitor. Just tell me if I need to adjust anything.
Okay.
Can you see it
Uh,
properly?
okay, yeah, I think it's good.
Can you?
Yeah,
Okay. All right. So, um, my project is based on predicting employee attrition using machine learning. So, let's dive straight into it. So, what's the overall goal? So, the goal is to reduce employee attrition, which is where the employee leaves due to natural causes. So perhaps they just move to another company or just leave without being fired or any other form of punishment. So, what we're going to do is leverage data that's provided to us to predict attrition so that we don't have to suffer the loss of productivity or wasted resources on someone if they're just going to leave in the end. So high turnover causes significant cost implications because at this point, a new recruit is likely to have gone through already like training programs as well as other things which the company has personally funded. And so for this reason, if a person were to leave, that would just lead to a huge waste of cost. And this can also lead to a loss of productivity because it disrupts workflow and existing teams that are there. And so this can also result in hiring delays because there's a slowing down on the project completion if people are leaving um, out of nowhere. And so what we want to do here is we want to build a model and an overall application which can predict this trend so that HR or other bosses can start putting in place programs or some sort of benefit system so that to further encourage the employee to stay with the company instead of just leaving them. So yeah, the problem statement is to address workforce turnover through predictive solutions. So the main challenge is that high employee attrition, as stated before, can lead to instability. And the solution is to implement a reliable predicting system so that they can mitigate the performance of the chance of attrition early, like I said, through programs or maybe some sort of benefit system. And the main key idea you have to emphasize here is the difference between reacting to the person leaving or predicting the person leaving. So if you were able to predict this ahead of time, that will save a lot of resources for the company. So for the overview of the dataset, we got a dataset provided by IBM on Kaggle, and there was a variety of features that were used, but in the end, the main features we used were the ones with the highest correlation, which led to a total of 20 features. And here's the distribution of attrition, the amount of attrition that occurred in the dataset. So 16% did commit attrition and the others didn't, and this was later balanced using techniques, but I'll get into that later.
okay.
So how do we actually select the features? So the very first step we used was one-hot encoding to convert the categorical data into like binary vectors and quantitative data because that's what's necessary to train the model. Then, due to the earlier imbalance I showed in the last slide between attrition and not, I decided to use SMOTE to handle this imbalance so that I could oversample the amount with attrition. And although this doesn't obviously guarantees accuracy, this can improve the model performance by making sure there is a decent balance between attrition and no attrition. So next, as I mentioned, I selected features based on correlation. And so the correlation minimum I decided on was 0.1. So features that had a correlation of more than 0.1 with attrition were kept and used in training. And this was to make sure there wasn't any increased amount of noise in the model because that can hinder the performance. And so, as I said, this resulted in 20 relevant predictors, which I used to train my model. So I went through quite a lot of models during my process of building this. This ranges from random forest to XGBoost to eventually logistic regression. So since this is a classification problem, there weren't a lot of models that I can use, but these are the ones I decided to test out. So in terms of random forest and XGBoost, these were decent models, but I found out that there was often a lot of inconsistency with these, and it also was lagging behind logistic regression in terms of the AUC and the accuracy. So ultimately, I decided because it was faster and it was more accurate, and overall it was just simpler for me to deploy onto my Streamlit app, I decided to use logistic regression. So after I decided on my algorithm, I went on to the next stages of my model development. So as I said, I chose logistic regression, then I scaled all my data to normalize the data range, and I used an 80-20 test train split. Train test split. So 80% of the data used for training and then 20% for test. So here's the model performance. So this is on a percent scale, and this is the metric is out of 100, but as you can see, the percentages are here. So this is 82%, even though it looks at the end, it's still 82%. So the accuracy of the model was 82%. And the precision, as I mentioned earlier, the precision took a significant hit due to the imbalance in the data set. And as I said, I used Smote to try to counter this, but it wasn't as effective as I desired it to be. So there was a hit on precision with 44%, but it's still not the end of the world considering the rest of the details. So recall was 62%, and then the ROC AUC was 80%. So it was overall a pretty good performance. And in terms of deployment, I decided to use Streamlit to deploy it. And I decided to create two types of UI, two types of data input into the UI. So for single employees, I use a slider feature to input the data using sliders. And then for mass batch analysis, I decided to have the feature to upload a CSV file so they can analyze multiple employees at once. So yeah, I built an interactive app, and then that allows HR to easily be able to analyze the performance, and it's really efficient and feasible implementation for the HR. So I'd like to transition to the um my demo here. So can I stop screen sharing and then let's share my
Yeah,
Streamlit app?
sure. And before you do that, I would really like to compliment your presentation, the design of the presentation, the transitions that you made, and even the way you presented. I really like that it very much.
Yeah, thank
And
you.
talking about the idea, this is something this has a really practical use case, right? And I totally agree with you on every point that you mentioned. That employee attrition is really crucial for organizations, for some big organizations, and you have pipelined it really well. And who knows, when you in the future, when you improve this and it works out in a very in a better way, we might be the one using it first.
Yeah. So
I
yeah,
hope so.
using better data sets, it's obviously going to get better and better. So this is just the
Yeah.
beginning.
Yeah, as you said, it's not the end of the world. You will obviously use some more data sets and everything. This was
Okay.
really good.
Tell me if
Yeah,
you can you see the thing?
yeah, I can see this.
Okay, so as I mentioned before, this is the manual employee input. So this is when you wanna, for the purpose of demonstration, we're gonna be using this because I don't have a pre-prepared CSV file to batch analyze. So here you can upload a CSV file and do the same thing, but I'll use the manual input for the purpose of the demonstration. So
Okay.
here, as you can see, these are the 20 features that I decided to use in training my model. There's ranging from age, total working years, etc. And there's also short descriptions of each if you were confused what it means. So to start out, let's say someone didn't have a lot of job involvement and they weren't very satisfied with their job, and they also didn't play a very significant role in their job. So if you were to project this attrition risk, you can see there's a very high risk of attrition because they aren't that committed to the job and they clearly don't like their time at the job. And this is going to make them highly susceptible to maybe offers from another company or just leaving to find another opportunity. And you can also, in another scenario, let's say someone really, really liked their job. They were somewhat satisfied with it and they with the job, and they really liked the environment. And they had a long time of experience with the company, let's say, and they were slightly on the older side. They spent a lot of time with the company and they had a very significant job level, and their job role may be something like a manager as opposed to a lower job role. So this would make it so that they have a significantly lower rate of attrition because they're so much more important to the company, and therefore they have a lower chance of leaving because say they have stock benefits, they have higher pay, and maybe they're more needed in the company. And this will lead to someone having a lesser chance of leaving a company. And you might have seen this with the earlier one, but I also implemented a graph feature to see specifically what you wanted to see. So you can zoom into certain areas, you can zoom out, and this can let you just visualize how the risk is being compared. And if you desire, you can also download it as a PNG so that you can later reference, because often HR is going to be doing this at a pretty large scale and you need to refer to stuff in the future. And so that's the risk of attrition. And I also wanted to show you my files.
Okay.
So yeah, I'll start out with the EDA because I feel like that's the first thing. So I did the standard EDA analysis. So the basic statistics, I checked null values, and then I cleaned up the data, no null values. And then the first thing I did was univariate analysis. So as I showed you before, some things are more likely to influence attrition than others. But first you need to find out how much of that data was actually prevalent in the data set. So here you can see the distribution of these features in the data set. Like these ages are the most significant, and then here it was pretty much even. And this shows the univariate analysis. And then if you transition to bivariate analysis, this shows how each thing correlates with attrition. So this shows how, for example, daily rate correlates and distance from home. And as I showed before, the more satisfied you are, the less likely you are to have attrition. So this shows how those correlations can occur, and I was able to draw conclusions using these charts. And then lastly, the multivariate analysis. So this shows how multiple variables can influence attrition, and also a correlation heat map of the features just to see how the things correlated and which one were more connected to others. And at the beginning of the presentation, I mentioned how I had a minimum requirement of correlation to include it to reduce noise in the model. And so this is how I determined that. So with this graph, you can see how things were correlated to attrition. So you can see here something like hourly rate isn't that significant. And so there wasn't really a point in implementing it in the program, but something like years in current role or monthly income, like I showed you in the Streamlit app, was a very significant thing. And so it was important to use these. And so I decided to use the higher correlation features.
Oh,
And then last, I'll show you the model.
okay.
Uh, so yeah, this one's pretty short, but as I said, I used um packages and inputs such as pandas, numpy, matplotlib, and scikit-learn. And so I used the Kaggle dataset as I mentioned before. I dropped the non-significant columns, one high encoding, I scaled it, and then I split the data into 80-20 division, and then these were the metrics that I showed you earlier in terms of accuracy. So yeah, that's it for my presentation.
Okay, yeah. You did a good demonstration